Greetings from Indonesia. We are the Nagapasa team from the Student of Naval Architecture and Marine Engineering, University of Indonesia, led by Eko Septia Hardy as the team manager, assisted by the Board of Chief, with the help of our team members, and also received full support from our team advisor. According to the mission of WFSA or World Ferry Safety Association to reduce ferry fatalities by designing a safe and affordable vessel, we would like to represent to you our design for Ferry Safety Design Competition, 2022. MV Triwitono is a RoPax passenger ship, designed to operate on the Brahmaputra River from the Port of Kamalabari Ferry Ghat Port on Majuli Island to the Nimati Ghat Port on Jorhat for about 20 hours. MV Triwitono has the following main dimensions: 34 meters length, 10 meters breadth, with 0.9 meters draft. MV Triwitono can carry passengers up to 150 people and has 6 decks consisting of 1 navigation deck, 2 passenger deck, 1 car deck, 1 connecting hull deck, and 1 engine deck. The passenger deck is split between 2 decks to accommodate 1 economy class with 100 seats and 1 business deck consisting of 50 seats. Passengers will also have access to a toilet on each deck, a mini restaurant on the economy class deck, a musola, and a viewing spot on the business class deck. We also provided central air conditioning on every passenger deck. At the connecting hull deck, the passenger will be provided with extra space for cargo and a suitcase addition. There is also a refrigeration room to keep a fresh product. The bridge deck consists of navigation room, medical room, officer room, and high VAC fan and filter room. The ship's main power supply will be provided by 2 generators set in connecting hull deck and complemented by 1 emergency generator set in the same room. The main motor for propulsion is placed on the engine deck below. The ship structure is designed by using IACS regulations and rules Inland Waterway Ship by DNVGL. The structural design stages start from calculating the load, calculating the modulus, determining the profile, and finally drawing the midship. We use steel material for the plating and construction of ships. For the resistance calculation, we use the slender body method with determining the form factor value using the Moland method for catamarans and the ITTC formula to calculate the additional drag coefficient. As a result, MV Nagapasa uses a pair of W5400 kW 8P electric motors to reach a speed of 15 knots with an 85% load. It gives an advantage to the design, which is more effective because the engine room becomes much smaller, environmentally friendly, has better maneuverability, and reduces noise and vibration, also resulting in higher efficiency and low maintenance costs. For the propulsion system, MV Triwitono is designed with 2 main generators of Mitsubishi Marine Engine S6R, PTAW with 545 kilowatts each. Is intended to reduce the size and weight, and when one of the generators is damaged or under maintenance, the ship can still operate at 12.5 knots. The generator is compatible with the SCR system to meet the IMO Tier 3 requirements. An emergency generator Mitsubishi Marine Engine 6D24 MPTA of 218 kilowatts is used when an emergency occurs to operate the ship at 8 knots. The fuel used ultra-low sulfur diesel with a sulfur content of 10 ppm mixed with 10% biodiesel and 10% ethanol that can reduce NOx emissions and does not affect the engine performance. Also aims to support the blended ethanol program in India. We also use MaxSurf stability to calculate the ship's stability, by planning the load and determining the tanks in the ship. The load case is divided into 3 conditions, such as full load condition, half tanks condition, and empty tanks condition. The calculation result will be using criteria based on IMO HSC Code 2000 MSC 98, 73, HSC 2000 Multi-Hull Annex 7 intact. If something happens that causes the ship to leak, conclude by the floodable curve that the ship will not sink at 95% permeability even if it has flooded 2 compartments. We also calculate the damage probabilistic assessment using IMO MSC .216, 82, as the parameter, which results in the damage stability that meets the criteria. At this stage, an analysis is carried out related to the ship's motion or seakeeping to see the characteristics of the ship when facing a wave under certain conditions. At this stage, an analysis will be carried out regarding the discomfort level of passengers and the ship's bridge, the value of the response amplitude of the operator, and the value of roll, heave, and pitch under certain conditions. Based on ISO 2631 standardization, the passenger discomfort is moderate at wave heights of 0.5 meter and 1.25 meter and serious at a height of 2.5 meter, except for the bridge location is severe discomfort. The results of this analysis are sufficient to prove that the ship can sail well in the shipping area. This is because the shipping area has a maximum wave height of 1 meter. The cost estimation uses ship work breakdown structure 100 to 600 to break down every component that we use on our ship design. We also calculate the operational cost at $800 per year and can profit about $300 per year. We use the net present value and payback period method to determine our ship investment feasibility, by assuming that the profit is always fixed. NPV greater than 0, the investment is declared worthy and the payback period is 5.72 years. That is a quick explanation about our ship design for the WFSA Design Competition 2022. Thank you for watching our videos. Goodbye.